going to start talking about the components of a vector. And the term components means parts. Okay, the components are the things that make up something. So the components of a vector must add to form the vector. So we're going to do an example. Here's a vector, all right? And I can take this vector here, call that vector A, and add it to vector B, okay? And I could say A plus B equals, we can call this vector R for result, maybe, equals R. They're tip to tail, so I draw them tip to tail, then connect from the origin to the end of the vector I drew. So R is the sum of A and B. So A and B are components of R. Now, is that the only way I could do it? No, I could go over here. I could go there to there, then over to there. We'll call this vector C and D. So they are also components of R because C plus D would equal R. So C and D are components of R. I could even add 3. All right, I could go from here maybe up to here. All right, and then over to here, and then down to there. Call this E, F, and G. So vector E plus vector F plus vector G equals R. So they are also components. All right. So how many sets of components are there? Well, I could draw my vectors anywhere as long as I ended up at this point. They would be components. So there are an infinite number of components for any vector. Now, the two that are going to be useful, though, are the horizontal, or x, and vertical, or y, components of the vector. So if I look at vector A here, I can draw in its x component, that's how far over it goes, and then draw in its y component, and then I could label this AX, I could label this AY. AX is called the x component or horizontal component of the vector, AY is the vertical component. And you'll notice, of course, that this makes a right angle down here. Okay? Now, we need to find the amounts of those components, and AX is the adjacent side of the triangle, and A is the hypotenuse, right? This is my angle, this is the adjacent, this is the opposite, this is the hypotenuse. Okay, so if I wanted to find the length of the adjacent side, I could use cosine, because cosine of the angle is adjacent over hypotenuse. All right, so it's going to be AX over A. And then if I multiply A times cosine theta, cross multiply, AX is going to be A cos theta. Same thing for finding AY, except for I'm going to use sine, because I have the opposite side is AY, hypotenuse is A, so sine is opposite over hypotenuse. All right, and I could use that to find the y component. There's some examples of this on the next page. Now, when you're finding the components, the first thing is to draw in the components. And they are vectors. A here is pointing up and to the right. So its components have to be pointing up and to the right. So the x component is going to be going to the right. The y component is going to be going up. We'll call this AX. We'll call this one AY. And I want to find the components. Now, remember, if you have to go through all the detail, you can. You're allowed to take shortcuts as well, and I'll show you that in a second. This is my adjacent side. This is my opposite side. This is my hypotenuse. So when I'm trying to find AX, this will be the long way, all right? I could say AX is adjacent. I know the hypotenuse. So if I write out SOHCAHTOA, or whatever mnemonic you use to remember sine, cosine, and tangent, adjacent hypotenuse is cosine. So I could say cosine of the angle equals adjacent over hypotenuse. So cosine of 30 equals AX over 60. Then I'm going to cross multiply. So 60 cos 30 is AX. I use my calculator and I find AX is equal to 52.0. Now, here's the shortcut. You're going to start recognizing pretty quickly that for a y, you're going to be using sine because it's the opposite and you have the hypotenuse. So you can jump to this and I wouldn't take off for it. But if you need to do the detail, if you're not quite sure what's going on, go ahead and do it. But I would jump to this when I do it. I would say a y is just going to equal 60 sine 30. So ay equals 30. So I'm going to put boxes around these, so those are my answers. So AX is 52 and AY is 30. The next one, we'll find B. Again, I have to draw in the components. Now B is going up and left, so my components, AX is going to be BX is going to be pointing left, and BY is going to be pointing up. Now again, I can label that this is the adjacent side, this is the opposite side. When I want to find BX, okay, it's the adjacent side, and I have the hypotenuse. Adjacent and hypotenuse is cosine. So I can write BX is going to be 60 cos 30, and BX is going to be 52.0. BY is going to be 60 sine 30, and that's going to be equal to 30. So right here, BX and BY, box around those. Now, there's one small problem. You'll notice that B seems to have the same components as A, but they're different. Okay? If there were forces, a force pulling you up and to the right is going to cause you to move differently than one pulling you up and to the left. So there must be some way of looking at these components and distinguishing between them. And the way to do it is anything going to the right or up, we're going to make positive. So AX is going to be positive because it's going to the right. AY is going to be positive because it's going up. But BX, since it's going to the left, we're going to make that negative. And then BY is positive because it's going up. So it's important that you're drawing in these arrows correctly in the first place so you know which way the signs are going to be. The last one is C, and C is just going straight down 40. And for this one, you don't have to make a triangle. You can just look at it and say, well, how much of C is in the X direction and how much of C is in the Y direction? And if I look at this, X direction is horizontal, this is vertical, so none of C is in the X direction, and all 40 of C is in the Y direction. Okay, then you have to stop yourself and think about signs. 0 doesn't have a sign to it, but CY, this 40, should be positive or negative. Well, the vector is going downward, so we're going to make it negative. So those are the components for that one. So whenever they're straight horizontal or straight vertical, you don't draw a triangle. Okay, one of the components is going to be 0, and the other one is going to be the total amount. Now, we can also add the vectors, find the resultants, okay, by using a component method. In this case, we don't have to draw it out to scale, so it's a little bit quicker, but we do have to use sine and cosine. So some people find this way quicker and easier. Some people struggle with this. But here are the steps. We're going to find the x and y components of all of the vectors. That makes sense. Now, step 2, we're going to find the components of the resultant by adding the individual components. So the resultant x is going to be the sum of all the individual x's. And the resultant y is going to be the sum of all the individual y's. And then the third step, construct a vector using rx and ry, we'll get to in a second. It seems a little confusing, but when you see it, it shouldn't turn out to be all that bad. So this first example, we have 20 newtons east and 30 newtons 40 degrees north of east. So I'm going to sketch this. We have 20 newtons straight east, and then we have 30 newtons 40 degrees north of east. So that means north of east is going to be up this way. Okay, this angle is going to be 40 degrees, and then this is going to be 30 newtons. All right, and I like to label these. I'll call this vector A and call that vector B. Okay, now We've actually done this problem already. So I'm going to show you that back here. So back on page 3, I think it is, we did this exact same problem by doing a scale model, and we got that the resultant was about 45, and the angle was about 23 degrees north of east. We should end up with about the same values when we do it using our component method. So going back to where we just were, right here. Okay, so the first step is to find the components of all the vectors. And so see how A is going straight to the right. So it's all in the x direction. So AX is going to be 20, and AY is going to be 0, because all 20 of A is in the x direction and none of it is in the y direction. And they're both going to be positive because it's going to, or the AX is going to be positive because it's going to the right. Now sometimes it helps to draw the vectors separate from each other. So I'm going to redraw the B over here. All right, I'm going to say it's 30, and I can sketch in BX and BY. Okay, B is going up and to the right, so BX has to be right, BY has to be up. We'll put the 40-degree angle in there. Now, BX is the adjacent side, so for the adjacent side I'm going to use cosine. So it's going to be 30 cosine of 40. And that's going to give me a value for BX of 23.0. And my BY, Y is the opposite side of the triangle, so and I have the hypotenuse, so I'm going to use sine. It's going to be 30 sine 40. And that's going to give me a value of 19.3. Okay, so the first step was to find the x and y components of all the vectors. Second is find the components of the resultants by adding the components. So we'll do this down here. Rx, you add AX plus BX. And if there's more, if there was a C, you would add that one and so on. So for this one, Rx is going to be, AX was 20, and BX is 23. And that's going to give me a value of 43 for my Rx. Ry is going to be AY plus BY. And that's going to be 0 for AY, plus our BY was 19.3, and that gives me a value of 19.3. So we've done the second step. We found Rx and Ry. The third step is to construct the resultant using that Rx and Ry. So my Rx right here is telling me to go 43. It's positive, so 43 in the x direction. So I make a new triangle. And in this case, it's going to be 43 in the x direction. And from there, I'm going to go 19.3 in the positive y direction because it's positive. So I'm going to go up 19.3. And then I'm going to draw in my resultant. And I'm going to find that, and I'm going to find the angle. Now, in order to find the resultant, this makes a right triangle, so I can use Pythagorean theorem. So r squared is equal to 19.3 squared plus 43 squared. And if I do that, I end up with r is 47 newtons. And then my angle, I have the opposite side and the adjacent side of this triangle. Opposite over adjacent is tangent, so I can write tan theta is equal to 19.3 over 43. And when I do that, and I do my work, I end up with theta equals 24.2 degrees. And it's north of east, because this 43 is pointing east, and I have to swing north of that to measure it. So we can write north of east. So the values we should have gotten We thought were roughly 45 and 23. We're pretty close, so we know we've done it correctly. This is actually more accurate than doing the scale model, because in the scale model you may be off a little bit in your measurements. So at the end of this, you should be able to find the components, the x and y components of a vector, and then also be able to add vectors using components.